Today we're going to continue looking at inequalities. We're only going to look at inequalities for, we looked at it earlier this week and then today, but then that's going to be it. Okay, so we won't do a whole lot more with inequalities at this point. So the diagram at right shows three possible ways to represent an inequality. Review the meanings of inequalities with your shoulder partner. Everybody know what all these are? Yes? Okay. Then generate the two missing representations from each inequality described in parts A through C below. So, this one, we've got it in symbols. In words, this would be x is what? Less than negative 1 1/2. I suppose if we could make it all words, couldn't we? Oh, let's do that. On a graph, that might look something like this. So should this be an open circle or a closed circle at negative 1 1/2? Should be open because it's not equal to. And less than is which direction on a horizontal number line? Left. Yeah, to the left. So it should look something like that. All right, here x is greater than or equal to 2. So x is greater than or equal to 2. Then on a graph, this time it's a closed circle because it's or equal to. So it should look something like that. And then C would be x is less than or equal to 2. So just the opposite of the one that we had previous. All right, let's take a look at some more real-world problems. It says represent the solution for each of these variables described below as an inequality on a number line and with symbols. So we have to do two things. So they've given it in words, we're going to do the other two. So the speed limit on certain highways is 65 miles per hour. Let x represent any speed that could get a speeding ticket. All right, so can you get a ticket if you're going 65 miles an hour? No. It has to be what? Well, could you, not will they, because frequently, I mean in reality, you can't speed in a passing lane. Yeah, the speed limit still applies. Okay? In theory, you could get a speeding ticket for anything greater than 65. Now, in reality, at least around here, generally speaking, depending on what the speed limit is, there's some grace involved in that. They usually don't, for somewhere between 5 and even sometimes as much as 10 miles over the limit, they're looking for bigger offenders typically. Gentlemen, is there a question? I don't know why you're turning around so much. All right, next one. You brought $10 to a store. Let X represent any amount of money that you can. Oh, by the way, we really should label that this is X. I sometimes forget to do that. You brought $10 to a store. Let Y represent any amount of money that you can spend. Okie dokie. Yes?
It's 10 is greater than or equal to Y.
You're close, but not quite. So a lot of people will say Y is less than or equal to 10. And that's partially true. But if we did that on a number line, and don't copy this down just yet, if this is 0 and this is 10, that would mean we could spend 10, and that would also mean that we could spend negative $12. Can you spend negative $12? No. So this is partially correct, but not quite. Can we spend $0?
Yes.
Yes. This is something that's called a, have you ever done a compound inequality before? No? Okay. So what happens is that Y has to be between 0 and 10. This means two things. This means that 0 is less than or equal to Y, and Y has to be less than or equal to 10. But instead of having to write two different inequalities, we can just write one and say, yeah, Y has to be in between those two. All right, let's apply that thinking to this next one. To ride your favorite roller coaster, you must be at least 5 feet tall, but less than 7 feet tall, so you don't whack your head on something. So, can you ride it if you're 5 feet tall?
Yes.
So we're going to include 5. Can you be 7 feet tall? No, it says less than 7. So on my height graph, you can be 5, but you cannot be 7. You can be anywhere in between those two. And frankly, that gets most adults. Not all, but it gets most of them. Any questions about that? Okay, let's go on to the back then. We have looked at least once, if I remember correctly, at a problem where Ellie is building this dollhouse. Next time, go to the back so you're not walking in front of everybody. Thank you. So she has two sets of boards that are different lengths. The long boards are 54 inches long. So the length of a short board is unknown. Ellie put 3 short boards end to end and then added on her 12-inch ruler end to end. The total length was still less than the 54-inch board. So let's draw a picture of that. So she's got these 3 short boards end to end. And those short boards are all the same length. We need a variable for that because we don't know what it is yet. Pardon? So let's just call it X. God bless you. And then she put her ruler on here that was 12 inches long. And then she's got a long board now. After putting all these together, it's still shorter than the long board. Do we know how much shorter? No. Nope. But we know it's at least some shorter. Yes. This is 54 inches. And this is 12 inches. So my inequality then would be, well, I've got 3 x's plus I've got a 12. Has got to be less than 54. So if I want to figure out the possible lengths of the short board, what we can do is take that inequality and we could cut 12 off of both sides, right? That would be fair. So we would cut 12 off of both sides. And I have 3x is less than 54. I'm sorry? Oh, sorry, I didn't subtract. Thank you. 42. And then if we want to find out about each individual board, we don't want 3 boards, we just want 1, right? So I'm going to divide that by 3 on both sides. 3 goes into 42 14 times. So the length of the short board is 0 is less than x is less than 14. Because a board can't have a negative length. It could be really, really short, but it can't be equal to 0 and it can't be less than 0. So for our graph for x, it's got to be in between 0 and 14. When you're doing these number lines, you don't have to put every single mark, but you should have something other than just one number in the middle. Oh, are you signing out?
Huh?
Huh?
I don't know.
Okay, is someone coming to pick you up?
Nope.
Where are you going?
I think I'm going to building 5.
I'm sorry?
Building 5.
Do you have like a note or something? I just didn't get any email or anything on it. Yes.
Like, what are the like differences between the open and closed?
So if it's open, it can't be equal to that. We're not including it. And closed means we are including that. So if this was equal to 14, we would fill this in. But since it's not equal to, we'll leave it open.
Huh?
Do you have something?
Well, she didn't really send the email to me. She sent it to her mom.
Okay, this is the first I've heard about it. Don't know why. Okay. All right, let's look at this last one. So we have 3 people, Jordan, Terry, and Morgan. They're going to have a kite flying contest. Jordan and Terry each have 1 roll of kite string. They also have an additional 45 yards of extra string. Morgan has 3 rolls of kite string plus 10 yards of extra string. All of the rolls of string are the same length. The girls want to see who can fly their kite the highest. So, since Jordan and Terry have fewer rolls of kite string, they decide to tie their string together so their kite can fly higher. Write an expression to show how much kite string Jordan and Terry have. Let X represents the number of yards of string on 1 roll. So Jordan and Terry each have 1 roll of string, plus they each have 45 yards of extra string. So if they tie them together, that's X plus 45 for one of the girls, plus X plus 45 for the other girl. So together, grouping the like terms, they have 2X plus 90. Now, Morgan has 3 rolls of kite string plus 10 yards of extra. So that's X plus X plus X plus 10. So that's 3X plus 10. Now the question becomes, how long does a roll of string have to be for Jordan and Terry, that's this one, to fly their kite higher than Morgan's kite? Well, that would mean that 2X plus 90 needs to be what? Compared to 3X plus 10. If we want Jordan and Terry to fly their kite higher than Morgan's. If they're going to fly it higher, do they need the same amount of string? No. So which one needs to be bigger? Why am I getting no answers at all? Y'all with me? This is Jordan and Terry rather. We want their kite to fly higher than Morgan's. What inequality could we put between these two? Someone said it, I think. Greater than. If they want to fly their kite higher, they need more string, right? I'm getting nervous when I get nobody volunteering. It makes me very nervous. All right. So to check what we're going to do, let's remove 2x from both sides. So we're going to take away 2 rolls of strings from each of them. That's fair. And then take away 10 from both sides, from one set of strings and the other set of strings. So x has to be less than 80. But it also has to be greater than 0, right? So it would look something like this. Any questions about that? Okay,